So, okay, and everybody can see that, I guess.
Yeah,
Yep.
you're up, Eric. I mean, John. Sorry.
Okay. So this is the basic. This screen, and this is EasyNeck. And there's a free version of EasyNeck that you can download. There are other ones, but every one is going to be pretty much similar. And this is where you see. This is where you build the antenna. So you've got frequency, and you set your frequency. Well, we want to build this for 20 meters, so it says 14, and you can get as more detailed as you like. And some of the other basics, ground type, uh, okay, real mini neck, you won't go too far. You can go to perfect ground, um, which may give you some ideas, but you can't make a perfect ground unless you pave the county with copper. Free space. It's good to compare antennas. Real, the mini net ground is pretty good. The high accuracy, either one of those, there's not going to be a lot of difference between the two. Wire loss copper, you can go to perfect wire, lossless wire, copper, aluminum, tin, zinc. We're going to use copper wire. Units, feet, obviously they're plot type, and we'll try to get to that. Azimuth, step level, none of that's all that. Okay, all turn to SWR, and we'll get to that. So wires is where you build the antenna. Okay, and we're just going to make a really simple dipole here. You got X, Y, and Z, and everything is, each thing is one wire. So this is a wire that goes from X is side to side, Y is front to back, and Z is height. And again, we set it to feet. So I like to start at the center being 0 and 0. So this wire goes from minus 16 and a half feet, and you can think of that as 16 and a half feet to the left, and it goes to plus 16 and a half feet. You can think of that as 16 and a half feet to the right.
Can I interject, John?
Yes, go ahead.
So if any of you are familiar with the EOC, we've got 3 telephone poles or utility poles. And you could think of minus 16 and plus 16 and 0. The 0 is the middle telephone pole, and minus 16 would be the northern pole, and the plus 16 would be the southern pole,
Yeah,
or some sort of representation like that.
yeah, that's okay, because we're going to feed this in the middle. Okay, and I have it set at 60 feet high. I'm going to use number 14 wire right here. Okay, and I set it for 111 segments. The segments are the more up to a point, the more segments you have, the more accurate your antenna model is going to be. It's going to slow down. More segments will slow down calculations. Back in the bad old days with slow computers, that used to be more of an issue where it would take forever to calculate this antenna 111 segments maybe, and there was a limit to segments on some of the free software. Dielectric constant, don't worry about that.
What exactly, John, is a segment?
Segment is you're taking that. We've got 33 feet of wire.
Okay.
Okay, and we're chopping it up into 111 segments.
Uh-huh.
Okay, and what the software is going to do is analyze the antenna currents in each one of those segments sequentially, and then put them together to make the pattern of the radiation. So the more finely segmented it is, the more accurate your pattern is going to be. Does that make sense?
Yeah, I was just wondering, is there some calculation you use to come up with the 111, or is it just a convenient number you picked?
You want an odd number, and I'm going to show you why in just a second.
John, are you talking about, like, say you're making a dipole with 2 segments?
Yeah, the wires have to be in straight lines. So if you want to do an inverted V, you need 2 separate wires.
Right.
Yeah.
Okay. The wires have to be in a straight line, each different wire. You can't do a circle. To approximate a circular loop, for example, you'd have to do a bunch of segments in start with a triangle, and then a square, and then a pentagon, and then a hexagon, and then an octagon, a nonagon, a decagon, until you are approximating a circle as best you can to do an actual circular antenna. Okay, that doesn't mean circular polarization. That just means circular antenna. So each one of those wires, and you can have many, many wires in a model. Okay, a simple inverted V would have 2 wires. Okay, and they would each would start at 0. They would go out a certain, and a lot of times you got to start working on a little bit of our old friends trigonometry and Pythagorean theorem to figure out what where they're going to end up as far as the Y and then the Z for the height, what height they're going to be. But you can see if you did it right, because there's a way to look at the antenna.
So I bet your Algebra 2 trig teacher loved you.
I bet he didn't, but he was a great teacher, by the way. One of my favorite teachers.
Yeah.
I enjoyed his class a lot. But yeah, it really it can get into a little bit of math, but it's mostly simple. It's mostly Pythagorean. A squared plus b squared equals c squared gets you 99% of the answers. So anyway, so that's where we're at with that. And let's see. Okay.
John?
So we're back. Yeah.
The way I think of this when you're talking about the segments is that in order to describe the antenna, which is not linear, what they're doing is they're using multiple segments to approximate the curve, because you can do linear regressions and equations for curves, and you basically approximate the curve with multiple short segments of straight lines.
And that's exactly what it's doing, Bart, is
I know.
Approximating a curve, and you can play with it, and you can take it from 111 segments and look at your radiation pattern, for example. Take that down to 1 segment and see what the radiation pattern looks like. Take it up to 311 and see what the radiation pattern looks like. It's one of the great things is you can play with this thing all day long. So anyway, so we got wires. Okay, so we're kind of clear on that. And then, whoops. Okay, sources. And this is where we're going to feed it. And here's why you pick an odd number on a dipole like this. Here's why you pick an odd number, because we're going to be 50% from N1. Okay, each wire has 2 ends, obviously, and this is from N1. We're going to feed it in the middle, so we want to be 50%, and that comes out right in the middle of an odd numbered segment. So give me one quick second. I'll call you back, okay? Okay. Sorry, my favorite son.
That was your math teacher.
So, yeah. Okay, so we're going to feed it 50% or halfway, going to feed it in the middle. Okay, that's going to be our source. Loads would be loading coils would be a very good example of a load that you would put in. You can model transmission lines, add transmission lines, whether it's going to be 50 ohm coax, whether it's 450 ohm ladder line. You can put in transmission lines if you want, transformers and L networks, and and you can really start getting pretty deep into it. But this will give us the basics of what we want. Now we're going to go to view antenna here, and everybody can see that.
Yep.
I can't see the entire thing, but yeah.
It's off the screen.
Let's see.
Maximize if you do.
Okay,
Yeah,
there you go. Yeah.
that's a little better.
Yeah.
Drag it down to the middle of your screen, John.
Yeah, it's
Bring
off
it
to the
down
upper right. No, it's still off to the right. That's
A little bit. There you go.
There you go.
Perfect.
Oh,
Was perfect.
yeah. There you go.
There, better? Okay.
Yeah.
Okay, so here's our Y and our X and our Z. And there's our antenna. And you can see that right in the middle there is the circle, and that's the feed. And you can see that I put the cursor right over it. You see that little pop-up box?
Yep.
And it says the wire is 33 feet long. 33 feet long. The segment length is length divided by number of segments. 14 gauge wire, and there's our end one is minus 16 and a half feet.
Move your cursor. There you go.
There we go, and that's
Plus.
Yeah.
It's plus 16 and a half feet. So that's what the antenna looks like, and that's just a good check too. Is this what I meant to design? Okay. So let's see. Get rid of that. Get rid of that. Okay. So, and then we'll take a look at the SWR, and we specified again the frequency at 14 megahertz.
Yeah.
Okay. And whoops, not the one I want. Take a look at the SWR. No, and we'll let it run. Okay, and here you set where you want to sweep from. And right now I have it set from 10 to 20, and this will go quick. Since we're only interested in 20 meters, we could set it from 13 to, in fact, we'll do that. We'll change that to 13 to 15. And
1.5.
Whoop. Yes, thank you. 13 to 15, and you set your frequency step.
0.5.
Read from file and all that stuff. You can do all that if you want to. There's a lot you can do with this, and all the other programs are pretty similar, but we'll run it like this. And
It should be done.
okay.
I
So
see
there's-
only a 10 segment part of your graph. Yeah. That's better.
Yeah, that's better. Yeah.
Okay, so you can see it's right about there. There's your SWR. 1.1, 1.5 up to 10. And
So
right there is your low point,
About 1.6 or so.
Yeah.
1.6, and that's right about what you would expect for what do we say? The height was about 60 feet. So That's right about almost exactly what you would expect for a 20-meter dipole at 60 feet. So that's okay. So that and okay, and then okay, and then here we go with the
Far field.
okay.
That's your propagation.
This is your okay, and
That's the radiation field.
this is your yeah. And it's, why is that looking like that?
So to wit, you are not expecting this radiation pattern?
Oh, it's something is not. It looks like all the radiation is going up, which is. I don't know. Let's see.
What's your distance from ground?
Yeah.
Your
what's
height?
the height above ground.
I think he said 60 feet, didn't he?
He said it, but I'm not sure if that's where it's set.
I would check that.
Let's see. Ah, crap. What do we do? Did I close the program? What an idiot.
You closed the program, didn't you?
Oh, what an
Your
idiot.
teacher's going to call you.
At the very least, you stop here.
All right, we'll start it up again. One of the nice things about this one, at least, is it stays right where it was supposed to do. So let's see. Oh, let me close that and let me.
Eric, you're joining from phone. You can see that image?
Nope. I'm just visualizing.
Nice. What a genius. That guy's amazing.
No, I've had,
There
so when
we
I
go.
see the radiation going straight up, it's like the wires on the ground, like an NVIS.
That's exactly what I thought. It looks like an NVIS, right?
Yeah.
Yeah.
Here we go. 60 feet. Yep.
Yeah. Okay, he got a 60 foot. Why would it look like that?
I don't know. I'm just winging this, so I didn't really have it prepared. Let's see.
Azimuth angle is 0. Oh, never mind.
Go back to
Step size is 1 degree.
Smith.
Change to azimuth.
Okay.
Far field. Step size.
Elevation. You got to set an elevation angle.
Go 90.
Okay, so there's
Yeah.
your classic.
That's better.
Okay, there's your classic. The other one was the elevation. Now we're looking at azimuth, which is a circle around you, as opposed to the elevation, which is above you. I don't know why that elevation plot came out like that. But that's, I'm going to look into that. But here's your, at 5 degrees, this is what you're in, and it's,
One might say that an antenna that you just modeled, John, would be good for American or, local, what I would say regional type transmission, right? I mean, literally, if you've got that type of azimuth or elevation angle, you're probably going to drop down. Your first hop's going to be somewhere in the U.S., maybe even your second hop.
yeah, there's something I'm missing here, because that's not, that just doesn't pass the smell test, for how a dipole, it's a half-wave dipole.
Right.
That's not how a half-wave dipole I mean, we can try, well, let's see.
Yeah, even 20 feet off, 10 feet off the ground is going to give you some normal propagation.
Right. It's going to give you takeoff.
We're going to cut that
Right.
to,
3 feet, okay.
Okay, and actually there are ways, if you have a lot of wires, there's a way up in here somewhere where you can bring everything up and down by a certain amount altogether. You don't have to go into each wire, but it was just as easy to do that. So
Right,
let's
if you're
see.
going to model a sloper or whatever, you can change those values.
Yeah, okay, so let's see.
Sorry.
Antenna and, okay. Okay, so the height now is about a half wave high. Okay, and we're going to, okay, okay, and that's, see, I mean, that looks about the same. Okay, and let's see, now we're gonna do elevation.
How's your arm, Eric?
It's
That's the one
actually
you were trying
sore.
to find, isn't it?
Yeah. Yeah, it was fine until last night. And it's like, oh man, this morning I woke up and was put my arm head up and it's like, I mean, it's not debilitating, but it's like somebody gave me a good punch in the arm.
Mm.
That's what it feels like. But otherwise, see, I get allergy shots every few weeks, so I'm used to sore arms anyway.
Oh,
But
boy.
so I've been doing that since I was a kid.
Well, I'm a diabetic, so I take shots every day,
Oh, there
sometimes
you
three
go.
times a day.
So needles are old hat, right? You know.
They're old hat, but they don't make me sore afterwards.
Yeah.
Sorry,
Okay.
John, we hijacked your conversation.
No problem.
John,
Okay.
this is the picture you're looking for.
That's the one, buddy.
Yeah.
Yeah, okay, so here's, so here we drop the height and you can see now it's starting to radiate better. And you can, if you watch the numbers, you see how they're changing with the elevation. So it'll default up to the max. That's what those lines are. And it'll, but you can
Oh, right. Sure.
bring them around to whatever elevation that you want.
Yeah.
So it's and that's let's see, one other thing I'll show you, two other things. You change the plot type to 3D.
You got to place. Okay, buddy. There you go.
Yeah.
That's an interesting looking plot.
Mhm.
Yeah, that's the 3D elevation and azimuth combined, and then you can slice it like that. And
Can you slide that a little to your left? Like grab the, yeah, right there. Just grab it and move it.
There you go. Yeah. Oh, too big.
is that no too big?
Go back
Okay.
one. Yeah,
There,
that's
that's
perfect.
fine.
Dude.
Yeah,
like
that's
that.
fine.
Okay, so there's the red line there is your elevation slice, and here's your azimuth, and here's your elevation slice. And it's just a different way of looking at it. And,
That paints a complete picture for my mind. I understand that.
yeah.
That's pretty cool.
Again, that gets you back to like that. If you show 2D plot, and you can slide them, I mean, you can play with this thing a million different ways, but so that's the very basics of how to build an antenna model. One quick check, kind of a quick sanity check, is to, let's see, where do you check it for? Okay, model contains loss. Down there, everybody see that at the bottom?
Yep.
Yes, sir.
Yeah.
Okay, and average gain is 0.799. Average gain on an antenna should be approximately 1. 0.799 is terrible as far as the model containing loss. Model contains loss doesn't mean necessarily the antenna contains loss. means the model does. And when you change ground description, ground type to free space, change your wire loss to 0. I think that's the 2. Okay. So you can't erect an antenna in free space. You can't find 0 loss wire, but
I bet you can make it in free space if you were on Mars,
well, okay.
Well, then you'd still be on Mars.
right?
Okay. Now,
Somewhere in between, maybe.
okay.
Yeah, somewhere in between.
So there's a basic
Right.
sanity check. Now the average gain is 1, which is exactly what it should be and what you would expect. Okay, so
You could say isotropic here, John.
yeah, well, no, it's still going to have a radiation pattern.
Yeah.
Okay.
Yeah.
But it's okay. Still got that radiation, but your average, okay, because you got peaks here and you got peaks here, but you got nulls here and you got nulls here.
Right.
And when you average them all out, it sort of proves the theory that antennas cannot create power. And you can push it around, which is what antennas do. You can push the power around, but you cannot create power. So,
Which you mean to say amplify?
uh,
Is that what you? Is that the?
antennas, if you amplify it in one place, it de-amplifies it in another place.
Right.
I like to think of antenna radiation patterns as a water balloon. You can
Yeah.
squeeze them any which way you want, but you don't get any more.
Right. Yeah.
That's a good way to look at it.
That's a good analogy. That's right.
Yeah. Another way that I've always thought about it is you got a flashlight bulb. And that's more or less your isotropic antenna. And it's going to radiate all around in every direction. And if you had a magic flashlight bulb, it would even radiate straight down. And it's not very bright in any direction, but it does radiate lights up the whole room. When you put a reflector behind it, like in a typical flashlight, all of a sudden that side of the room gets very bright and that side of the room gets very dark. And that's your front to back ratio. Okay, that's how Yagis work, or beam antennas or gain antennas. It gets darker in one direction, so it can get brighter in another direction, but the bulb didn't get any brighter.
The point is, you appear more intense in one direction than in every direction.
Yeah.
Yep. So, and there's free modeling software. EXNEC has a free version.
For NEC too. 4NEC 2 is free as well. That's the one I use. It's pretty neat.
I know Eric likes that one, and that one is. I played with that, and I didn't see any. I know EXNEC better than I know 4NEC 2.
Yeah, it's just they've same engine underneath. It's just a different kind of front end. That's all.
Yeah, and they'll give you, they should give you virtually identical results.
Yeah.
But the thing to keep in mind with antennas is, well, one thing to keep in mind is it's one thing to say, wow, 3 dB gain is double your power or half your power, double your power. Wow. As a widely violated rule of thumb, one S unit is 6 dB. So 3 dB is half of an S unit. And how often will half of an S unit make a difference between making that contact and not? So heroic efforts for 3 dB gain are often
This is quite interesting.
not worth it. And
Sure.
the
Hey,
same.
John, on your original dipole there, what if we feed that ZO, change it from 50 to 70 ohms? What's that do to the SWR?
My guess is it's going to make it just about perfect, Jim, but let's, okay. There's a dipole and I think you probably know dipole. Let's see, whoops, no.
Well, I know the military, they use a lot of RG11 transmission line feeding dipoles, which is
Yeah.
75 ohm.
Let's see, where do we change that?
On SW, I think on SWR there was a point there.
Yeah.
Where did I see it? Maybe not.
Okay, so sources. No. Crap, there's a place to do that in here, and
Pick microprocessor.
no.
Dip switches. Pick. Multiple days. I only need 2 or 3. DTMF.
If you run that report, is that where it was after you ran it? The SWR report?
Let's see. Well, we could try that.
I was thinking,
You know
I
what?
saw
that
it there
might be-
somewhere.
There we go.
There it
Yeah.
is. Okay.
Yeah, there. Yeah.
You're better at this than I am. Yeah, see that? Okay, good
Okay.
point, Jim. You see how it made it just about
Yeah, just about 1-to-1.
1.055
Yeah.
there. Because theoretical half-wave dipole is 70,
Three.
I think it's 72 ohms is half-wave dipole in free space.
You don't see too many hams using the 75 ohm feed lines. You know,
It's hard to get good quality 75 ohm feed line. You can get a lot of junky stuff, but it's hard to get good
RG11
quality.
or something like that.
RG11 is, yeah, it's not common.
Right.
There's any number of
Thanks, buddy.
different things that I could tell you about, but trying to explain to people why it doesn't matter, or it can be better to use 75 ohm instead of 50 ohm is just half the time you're just pissing in the wind. You know, no, it says it's got to be 50 ohm. It's got to be 50 ohm. And there's, it's just.
Well, the reality is an antenna's impedance is not fixed. So it's never, you're only going to have a perfect match on one frequency on one, it as we move up and down the band, the impedance of the antenna changes anyway. So trying to lock into the idyllic theoretical impedance with the feed line is not productive.
Most people don't understand the concept, though. That's the problem. We're trying to relate the unknown to the known here.
Yeah.
And most people don't realize that. They think, well, it says 50 ohm. I got to live with 50 ohm. The reality is much different.
Yeah.
Well, there's I think the majority, well, I suspect the majority, certainly many hams don't understand that a low SWR does not mean that you have a good antenna.
No,
And
no,
a
that's
high-
true.
high
And we proved,
SWR
we
does
proved,
not mean that you have a bad antenna.
I would 100% agree with that. And look at the G5RV that we have when it's operational. That thing loads out, and I don't mean resonates, but it loads out on 160 if I put enough power into it.
Yeah, you're just heating the air
That's
at
it.
that point.
I'm heating transistors and resistors and whatnot in the tuner, and
Yeah,
maybe
and the
killing a few
coax.
birds,
Well,
killing a few birds in the process.
well,
true.
I'll give you a great. Okay, we can stop the share.
I think that's why you want to tune the antenna, not match it, or tune it, over matching it, if you will.
Well, I'll give you my favorite example is to build a 40-meter dipole and make it a perfect 40-meter dipole. SWR 1-to-1, yada, 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 feed it with RG8X. Losses are, you know,
There's Pop.
50, 100 feet RG8X. Your losses aren't too much. You know, works great.
Sorry.
Now I put a tuner in the shack and switch to 20 meters with that same antenna. Okay. 100 feet RG8X, you switch to 20 meters, and your tuner sees, what's the number? 6-to-1, I think. About a 6-to-1 SWR. How much of your power? 100 watts goes out. Tuner matches to 6-to-1. How much radiates as RF, do you suppose?
How many feet of coax, which in your example?
100 feet.
Okay.
2,
Okay. And the answer is
10.
no, it's not that good, Rob.
I was just guessing, dude.
It's about 6.
Okay.
Yeah.
Okay.
Yep.
Okay, your what was a half wave dipole, more or less on 40 meters, has become now more or less a full wave dipole on 20 meters. And the impedance of a full wave dipole approaches infinity.
Yeah.
Your SWR at the antenna feed point is astronomical. So your 100 watts, because you've got the tuner there, the magic antenna tuner, your 100 watts goes up and it's that almost infinite impedance, and most of it gets reflected down.
Yeah.
But because the losses in the coax now are so high because of the elevated SWR, as that loss goes up and down, your tuner does not see that loss. You see a 6-to-1 in the shack. Without the tuner, you measure a 6-to-1 in the shack, but that's not the true SWR at the feed point.
Right.
Okay. So you switch to some lower loss, some nice LMR 400, say, or something like that. And instead of 6 watts out, now you're getting 12 watts out or 10 watts out. So, yeah. Now, interesting thing is, switch to ladder line, and all of a sudden, all those SWR problems don't mean shit.
Right.
I was going to ask about that.
Okay.
Yeah.
Ladder line is as close as you're going to get to lossless feed line. In most cases, it's.
Can you run that in your model? I'm obviously I can't see it, but I'm visualizing.
You can. I'm not good at doing it, and I certainly can't do it quick on the fly.
But the reality, even if the SWR is measured, even if it was 10-to-1 or 20-to-1, even some number like that, you still end up with probably 90 some plus 95 plus watts still going into the wires that are radiating. Yes, even at 100 feet, even at 100 feet of feed line.
Exactly. That's
Yeah, that's why when I see people building, multi-band dipole, just running a big, much wire as you can left and right and feeding it with coax and trying to use it as sure, you can use it with a good tuner, you can tune anything, but, you're probably going to get maybe one band where it's efficient. The rest of it, you're creating an early spring with a lot of heat.
Well, and of course, proving that QRP works well, even if you take that 40-meter dipole, put it on 20 meters, you'll make contacts.
Yeah, people say, "Hey, I'm talking to people. It must be working."
Even if all you got is 6 watts going out,
yeah,
you'll make contacts.
I've made contacts when I was on the dummy loading of EOC.
Yeah.
Stand by. I'll be back in a minute, guys.
Okay.
Sure.
And so I guess this begs the question, why not use ladder line all the time?
Not as
I'll
easy.
second that.
It's often difficult to get ladder line in the house.
Yeah.
Well, yeah, you're gonna have to switch it to coax on the way in, but
there's not a lot of other reasons not to use it all the time. It's not as convenient. It's not just screw the connectors together. It takes more work, and more work means hams are like everybody else. Hams are lazy. If there's an easier way to do it, and no one is telling them different, and really being able to explain the difference and saying, well, you could be doing so much more better. You could be making a lot more contacts. You could be, I'll just use the coax. If you've got an antenna that's well matched, the losses in the coax get pretty small in most cases until you really start getting into long runs and higher frequencies. Loss in coax goes up linearly with length. 100 feet is twice as much loss as 50 feet. And loss goes up with frequency. Loss goes up as the coax diameter goes down. So that's all things that you need to consider. But a lot of hams don't want to bother learning. A lot of Elmers don't want to bother teaching. Put up a G5RV.
So the first thing I do when I'm going to try and help someone out and they have a G5RV and they're having some issues or not, I take a wire cutters and I cut off the coax, or I just cut it right off at the feed line and we just run new stuff, or just extend the ladder line part and go all the way to the shacker as far as I can. When I get to the window, we do some whatever creative option to get it through the window sill, usually like where I am now in my shack. I'll bend it right through the sill. And then on the other side, I'll run some coax, try and keep it 10, 15 feet or something like that, and then run it to a tuner or some other, try and keep that part of the run as short as possible. Just so you don't have any of the kind of stray radiation that can happen from ladder line inside the house. So I go all the way into the house, maybe an inch after the sill, and then do maybe again, depending on the antenna, some sort of a balun just to make the transition. But in some ways, sometimes you can do it straight. I know, John, you have some very creative ways as well. So, but anyway, ladder line if you can, and if it makes sense and it's not inconvenient to get it into the house. But if you can do that, that's pretty much the only reason. That's the only speed bump to not using ladder line all the time, like John said.
Yeah, ladder line also does not like to be near metal.
Right.
You want to keep it, further away from metal, the better, but at least about 6 inches at least
And
6
then
inches.
just make
away
sure
from-
any cross that you do, make it as close to right angles as possible. So it's the shortest crossover.
So, and you cannot bury lateral line. You can't lay it on the ground. It can be affected by the SWR can vary with weather, although elevated SWR on lateral line really doesn't, as we said, really doesn't affect it. So, so that's, but if you, unless you have a dedicated antenna for a single band, if you're looking for multiple bands, lateral line is the way to go. And or if you're going to use a tuner, the place to place the tuner, the place to put the tuner is at the antenna feed point, not in the shack. And again, that's less convenient, because you've got to run, somehow you got to get power to that tuner. Somehow you've got to get probably control wires to that tuner. So again, that's more work. But that's the proper way to do it, is to match your antenna at the feed point. And then you've got, in theory, you've got 50 ohms resistive at the antenna feed point on the inboard side of the tuner. And then the losses in the coax are not that bad at all.
Yeah, then it's just the efficiency of the tuner at the feed point.
So, but that's
complicated.
Oh, okay.
Have you ever done one of those, John? Have you ever put a tuner? I've never put a tuner at the feed point, but
oh yeah,
people...
the ICOM. I have a bunch of ICOM radios, and the ICOM AH4 antenna tuner is, I think, quite a bit about it. I like that tuner a lot, and there are other ones. LDG has a remote one.
Right.
I believe our good friends down in Mississippi, their MFJ probably has one. I don't know that I'd buy one, but they probably have one. But if you've got an ICOM radio, AH4, and I know Yaesu has one that mates with their radios. Kenwood has one that mates with their radios.
The Europeans got a bunch too. I mean, some of those things really work well for remote tuners and remote antenna controllers.
SGC makes a bunch of them.
So yeah, there's
Yeah,
manufacturers out there, and then all depends on what you want to spend on your shack, literally.
Yeah, the ICOM one I know is kind of pricey. I do like it a lot, but it is kind of pricey, and if you're running high power, the ICOM is, I think, rated at I want to say 125 watts or something like that. So if you're running high power, the ICOM's not going to do it for you.
No.
But power is no substitute for skill. And power, no matter how big your amplifier is, it will do absolutely zero for you on receive. You're not going to hear them any better. No matter how big your amp is, you're not going to hear them any better.
Isn't that true?
So
I think a lot of hams don't think of that the losses work kind of both ways. I mean, you're muting the receive as well as inhibiting and being inefficient on the transmit. It's a two-way street.
Yeah.
Yeah. So that's
exactly.
To eloquate that point, you're right about that, Eric. I've always felt that my station, because I don't use QRO, I don't use power beyond 100 watts. If I could hear the guy, I can work the guy. And that's always been very true at my station for whatever reason. And I think when you've got an amplifier at your station, there's no way you can possibly get a preamplifier to work in the opposite direction for your receiver. It just doesn't work that way.
Right.
So if
right.
you can't hear the guy, he might be able to hear you. You're just never going to hear him.
Right, and it's so much for a QSO, right? If you can't hear him, doesn't make any difference.
Right. You
don't know
had
what
there's
you
two
can't
parts
hear.
of a conversation: listening
Yeah,
and
yep.
talking.
Well,
Yep.
one of the old sayings is, if you can easily work everybody you can hear, you're just not hearing enough.
That's good. That's good.
You know,
Yeah,
but
sure thing.
yeah, if you know, power is sexy, you know, and you know, I got the biggest amplifier. I got this. I got this. I got this, and you know what? Money put in antennas is worth 10 times as much as money put into amplifiers.
Here,
If
here.
you- if
That's
you've
right.
if you've absolutely maxed out what you can do with antennas on your property, okay, then you still want more. Yeah, okay, you know, buy that amplifier. But you know, until you've got a real good antenna, you know, but that's
No matter what your budget is, you can get more bang for your buck with the antenna. No matter what the price, if it's $200, $500, $1,000, whatever you're spending, money put into the antenna system is going to outweigh the what you're going to get with the crappy antenna and just trying to pump power into it.
Right. Right. You know, the icing on the cake here, I think, is if you've got that kind of cheddar that you can buy like a tower with stack monobanders, the icing on that cake is to put QRO on it. Because no one's going to be able to compete with you. So now you're no longer a little pistol, you're a big dog.
Yep. That's
put your money into a 200-foot tower instead of a 100-foot tower.
Right.
So
I don't see anybody here that's got a 200-foot tower, John.
I just took mine down the other day, Rob. You should.
Damn it, John. What the hell, man? I would have bought that from you.
You see some of these guys, they have towers and antennas, and you see the QSL cards or something, or on QRZ pictures, and it's like, wow. And what did that cost him? And that's the first thing I think when I see all this stuff. How much money did he put into that system? You know, and the thing is, you just don't know whether it's actually paying off.
As
It
with
looks
anything,
great.
as with anything else, there are any number of people out there with way more money than brains.
It's kind of a manhood thing. I'll put, you know, it's just making it compensating maybe.
Yeah, I mean, how many guys, you know, piss away their money on buying these handy talkies because they got 9 watts instead of only 5. I mean, the fact is they probably don't have 9 watts anyway. They probably only have 5 watts, but you know, and they use crappy antennas. But hey, I got 9 watts though. You know, I'm king of the hill with my 9 watts. But
I've never operated more than 100 watts. I mean, it's barefoot radios with good antennas. They're going to do the trick, and you know, it's fun. I visited stations before and flipped on, you know, some juice, but I think it's just more satisfying to have to just try and work and be as efficient as possible. I mean, that's kind of that's part of the ham radio FCC code, right? To use the least amount of power to conduct the operation. So it's just kind of by statute as well. So anyway,
right, so
well, I'm going to get back. You did a really nice job there, John, and I'm just listening on the phone and good visualizations. That was pretty cool. I'll wrap up here in just a minute or two, then I can get back to a little bit of other stuff. Was there a question out there? I heard somebody.
No, I said, Ted, does that answer your question?
Well, let's say it's been very informative.
That was a great thread. That was a
I
great
will
thread you
have
started.
many, many more questions for many, many more years. Let's put it that way. You never stop learning stuff.
Ted, I've been licensed for 32 years almost.
There's always
And
something new.
I keep learning stuff.
Yep.
When I stop learning, send flowers.
That's true of all of us.
So,
Absolutely.
yeah, it's, there's
Modeling is fun, and you did a nice job, John, giving a crash course here that with a couple of real world examples. So real cool.
Yeah, I wasn't really even thinking about doing it, and it struck me at like 6:30. Hey, I wonder if. Well, first I said, I wonder if I have EXNEC on this laptop. So turns out I did, and I had no idea if that was how the screen sharing would work. So that's good to know that worked. So maybe we'll work that into some sort of a more elaborate presentation at some point. But and I'm by no means an expert on modeling, but there's a lot of resources. ARRL had a book, and I believe it's out of print, but they had a whole book on antenna modeling, and it's kind of outdated. It's probably 15 years old anyway. But
That the one they used to supply the EXNEC models with?
They might I think the EXNEC, the free version I think came with the antenna book.
Yeah.
But they had a course, and this is going back, it's probably 15 years. They had a course online, very early precursor to some of their newest efforts, but it was some sort of online course, and in fact it was L.B. Seebeck, who's been dead for close to 15 years, I guess. But as far as antenna modeling, L.B. Seebeck, W4RNL maybe. He was just God as far as antenna modeling go. He really, really knew all the ins and outs and all the things to watch out for, and the tips and trips and tracks and traps. And I'm sure I haven't really paid a lot of attention to it the last few years, but there are other people out there that really, really know the subject well. I really only scratched the surface as far as what you can do with it. You can model some, even with the free versions, you can model some pretty complex antennas. You can model Yagis and certainly inverted V's, V-beams. Ted, I know you were asking, sort of the whole thing started with asking about a V-beam. And I think if you model a V-beam, you'll find out that the difference in the gain between that and the dipole is not as much as you would think.
Right.
My main concern was just trying to determine what I can fit back here between the trees. And
how much distance? What you were gonna measure? How much? What do you have point to point, approximately?
Well, that's what I'm trying to find out. I got to get one of those big tape measures and see exactly how much clear space I have, and we'll probably have to get somebody to trim some branches out of the way, because everything in the back here is just wild baloney. It's just there, and I kind of figure some of this stuff is. It's not going to be convenient to hang an antenna in. It's going to be in the way, so it's going to have to get cleared away. And as far as getting it up into the trees, that's something I can't do. I got to get somebody who can climb trees.
There's tricky ways that would. So what town do you live in?
Waterbury.
Oh, all right. Well, you're almost closer. I'm over in Farmington, so I'm probably closer than you than over to down in Meriden way. But I know a number of us. once we're past the COVID issues, of course. But if you want to mess around and build something from scratch, I'd be happy to do that or play around. That's just really cool. And there's a lot of ways to get stuff in trees without climbing, and that are very resilient with some counterweights. I mean, I get stuff up 80, 90 feet on, from point to point, and just using slingshots, fishing weights, fishing line, and some very clever ways of pulling ropes up that we've learned for a long time. So feel free to, if you want to do something like that, I'd be game to pitch in and brainstorm, and I'm sure others would do likewise. That's fun for us.
Oh, I'm sure you would. Yeah, and I appreciate the offer. And like I said, I just waiting for the rest of the snow to melt and for it to dry out enough back there so I can go down and actually take a look. The land, after you get to the end of the yard where the grass is, it starts to slope down, and then all the trees and junk is down there. So it's, this is what I have to do is just figure, okay, access and how wide is it? Just how much. I have a feeling that certain antennas, you're going to want to mount it in the tree behind the other tree. And that's the problem. This, one tree in the way of where it actually has to go. So I want to find, if I put it between here and here instead of there and there, will it fit better? So
take some pictures. You want to take some pictures?
Because, I haven't really looked at it seriously until now. So I really have to see, how wide is this opening really?
How wide you can get a pretty good estimate of that, Ted. Go on Google Maps and zoom in on your property, and then right-click the map. It'll let you draw point to point and tell you how it'll measure the distance for you.
Oh, that would help. Yeah, I didn't even think of that. Thanks, Mark.
That's good.
Give it a shot.
I mean, it's not accurate, but it's ballpark for sure.
Yeah, well, like I say, if you get it within the near so many feet, it's like, you don't want to be off and say, oh, I'm 30 feet short. So
you can get, Home Depot has 100-foot tapes, and they're probably.
Yeah, I think that's what I was going to do. Is tomorrow, as a matter of fact, I'm going to run down there and see if I can get one.
Yeah,
a friend of mine had one. His dad used to use it when he worked for the bank to, survey properties for mortgage. But my friend's got one, but he's in Florida, so it's kind of hard to borrow it from him. So I figured, well, for the few bucks it's going to cost, I'll just go down and buy one.
I bet they're not more than $20.
They're about 20 to 25 bucks. I've checked online, and I said, well, I can just go down here locally and probably pick it up, just as well. Like I said, once it dries out back there, it'll be good, because now with all the melting snow, it's going to be pretty soggy. So I'm going to wait until maybe, sometime next week or so, and hopefully I can get down there and just take a few rough estimates. And, if I've got 60, 70 feet between trees or so, I figure I'm doing pretty good.
Oh, that'd be cool.
Yeah.
And like I said, if you need stuff getting up into trees, that's let's see. I had another question. I forgot what it was, but yeah. Oh, John, have you ever seen Rod Lane's air cannon for launching stuff? You ever seen his air cannon?
I don't believe I've seen.
Oh man, he built this thing that's unbelievable that launches tennis balls, and it's pressurized by one of his compressor tanks. And this, you could literally put something 300 or 400 feet in the air easy. It's incredible.
Yeah,
it's dangerous.
I have one.
It's like a potato cannon, basically.
It's like a potato cannon. It's like a potato cannon.
Yeah, exactly. I have one. I have one someplace that's, I don't know where it went to, but it's somewhere in the shop. So yeah, everything is somewhere.
Everybody, yeah. Okay, great stuff. Maybe next time I'll be Zoom enabled here, but this was fun just listening in, and I think these Elmer nights are great. I think that's really important to me when I was a little kid, and had some really good Elmers. So this is nice way to share stuff, and it's good. And like John, like you said, it's a continuous learning process. So nobody has a monopoly on this. So it's good stuff. So, all right, folks, everyone have a nice evening, and good chat and great topic.
All right, good. Regards to Elsie.
I will do that. I will. All right. See you later, John. And
Okay.
everyone else. Take care now.
Take
Good
care.
night.
Yeah. Yep. Bye-bye.
You know, John, I think I bought the last roll of 600 ohm ladder line that Hatries had when they went out of business. I still got a chunk of it hanging up in the garage there. I took a pane out of a window and I put in a sheet of plexiglass in that pane, bored 2 holes in it, and I got 2 ceramic feed-through bushings to go through the plexiglass. Set up the kilowatt matchbox just inside the window, and used that to feed everything. And I had all kind of different antennas connected to that thing over the years. It worked great.
Yeah, somebody was making it again. The 600 ohm.
Yeah, I think somebody's making it. Yeah.
It was true ladder line, real ladder line, something like that. We had talked a little bit, but he didn't seem too interested in having dealers, and I don't know whatever happened to him. And I met him at a show. Might even Deerfield. Might have even met him at Deerfield, but I haven't seen him in a long time. I don't know what happened to that, but you know, it's the true ladder line is, if anything, even a little more difficult to work with than what we call ladder line, which is really window line, which is, everybody calls it 450 ohm, and it's only 450 ohm if it's 18 gauge wire, and that's a whole different thing to get into. But
I think we used to use number 12 at 6 inches on the spreaders for the 600. I think it was 6 inches, maybe it was 5 inches, but it was pretty wide.
That was even higher than that. The 600 ohm is, I think the spreaders are like 2 inches.
2 inches?
Yeah.
Okay.
I know the 450 is about 1 inch wide, and the impedance is basically determined by the gauge of the conductors and their spacing.
The space between them.
And then the dielectric constant of whatever's in between them. So the window line has some plastic and some not, and the true ladder line actually does look like a ladder, where it's just a round, you could think of a round wooden dowel, which is how the old timers used to make them.
That's what I have. There's the only thing that's on there is the spreaders. There's the bare wires and then the spreaders. That's it.
Yeah, and that's it. And there was somebody selling packs of plastic spreaders for a while too. You know, people start making these things and then find out they're not getting rich on it, then they give up on it. So, but the what we call ladder line, the 450 ohm, what we call 450 ohm, what we call ladder line is
Yeah, it's a ribbon stuff.
Yeah, it's got the windows cut out of it and whatever. And that's about the closest.
I think that is twin lead almost.
Um,
Twin lead was 300, but you know, close to.
Yeah. If you remember the wire that went to your
TV.
Yeah.
Back in the old days, a wire that your dad put up for connecting to the TV antenna in the attic, that was 300 ohm.
Yeah, but how much RF could you put through that? It was made for receiving.
Not a lot, but they make
it bigger.
Every now and then they make 300 ohm window line. There's only one company that makes the ladder line. One company in the world that makes it, which has been they're under new management over the last few years, and they are much much improved over where they used to be. So the old people were, oh, what a nightmare to deal with. But
What's the company?
JSC or Seminole, their real name now is Seminole, like the Indians, Seminole wire. And they are, I tried sourcing the wire. I thought about having some made, and it was just completely frustrating trying to deal with the old owners. And there was very few people that had any interest at all in making it. And most of them were saying, well, yeah, we can make it, and the minimum order is 250,000 feet, 500,000 feet. You know, and I would
A little bit more than you need.
with the old manufacturer. I sold enough of it that I could justify getting 10,000 feet at a time, even though it took me a while to get rid of it. But 250,000 feet, more money than I was going to put into one product. So,
And if you could get a national monopoly and be the one and only U.S. supplier, US retailer.
I thought about that, and I just couldn't move enough product fast enough. So anyway, new suppliers, and so.
Okay, guys, I'm gonna
Hey,
say
we get
goodnight.
Hey, Bob.
Nice presentation. Good
Yeah, it was.
questions.
See
Very
you
good.
later. Yeah, that was interesting. I'm gonna get out of here too. See you, fellas.
All
night.
right,
Okay.
all right. We'll let you go. Good night.
No, I guess we're pretty much done. That was good. That was very good, John. You know, really helped.
Good.
I mean, you know, every question generates two more. So, you know, it's one of these things, you could talk forever on this stuff. And,
Oh, good. And I've been known to talk forever on stuff. So
well, you know, it's just like anything else. One thing leads to another, you know?
yep.
And the minute you get to one point, you say, you don't want to leave this out because it's relevant, but, you know, in any given situation, it may be more or less relevant, so you don't know.
Well, it's download some of the software and see what you
Trying to
like.
figure out how the software works, right?
But yeah, just keep in mind the smell test. Does this seem like a realistic, for whatever reason that plot that I showed didn't seem right to me, and I don't know why, and I got to figure out. Maybe it is, and maybe just one of the settings I had was just.
I was kind of thinking it's probably just the setting. There may be one thing you left out or something like that.
Yeah, I haven't, honestly, the whole thing occurred to me last week when I answered you and said, antenna modeling software can answer a lot of questions. And I this afternoon, as I was thinking about tonight's net, I said, I wonder if, so I had absolutely nothing prepared. I haven't played with the software in, I don't know, probably a couple of years. So I don't remember all the little things, but yeah, there's the that check for the loss. That's a really good, quick little, let you know that you haven't made any really egregious mistakes.
Yeah. Well, it's always nice to say, okay, we seem to be in the ballpark here, and you feel confident enough to say, okay, let's put it up and see what happens.
Yeah,
but the modeling software is just sort of to get you off the ground.
It's great. It's great for comparing. Often for comparing two, 3, 4, 5 antennas, and if you start with it and say, well, what happens if I raise it up to?
Thanks, Kay. You're welcome.
this many feet or lower it down that many feet. You know, what happens if I make it this much longer, this much shorter? What happens if it's an inverted V? And what happens if I change the angle
That, yeah.
like this to like that? You know, it's great for comparing, and you know, it's like as I said earlier, in theory, everything works in theory.
Yeah. Well, like I
Uh,
say, it's something, and like everybody says, that you get to the point where you say, you just kind of have to put it up and see what happens.
yeah,
And,
yeah, exactly.
so I look at it this way, I say, if you were to see what I'm talking about, it would be much clearer. As a matter of fact, if I should need anything, I could come down and I'll draw you a little diagram of what I'm talking about ground wise here. And you probably get a better idea of what I'm dealing with. But my main concern is just finding an antenna that's, going to work on a number of the bands and is going to work better. Right now, the only thing I've got for HF is the antenna I borrowed from the club, which is that vertical that Jeff was saying somebody ran too much power through the thing. So it's something inside is screwed up. It works, but not too well. So I had only planned to keep it for a little while, and then COVID hit. And I said, well, I can't return the darn thing, because we can't get into the shack or the club. And I said, well, then the winter hit, and I said, well, I can't put anything up. It's too darn cold. As a matter of fact, when we put that up, it was almost too cold to be outside. So I said, well, okay, just keep going. But now spring is coming, and I said, this would be a good time to get something up there, or at least know what I want to do and have a plan. And
Yeah,
if I
no,
get
it's
that far, I'd be really happy. And
no-
like I said, if I do have to clear any branches or anything, I try to have that done before they get full of leaves.
yeah, it's always easier before the leaves come out.
Yeah. The nice thing is, because it's just the woods, I say, look, chop them off and just let them fall. There's nothing back there that is going to bother it. So you don't have to clear a lot of stuff away. You just have to get it, just let it fall out of the tree and lay on the ground.
Yeah.
Yeah.
All
All
right.
right.
I'm gonna say goodnight here.
Yeah, me too. That's very, very interesting, and thanks a lot.
No, my pleasure. I'm glad you learned something if you did, and I just make this stuff up and people believe it. So
I think a lot of
Alrighty.
people do.
take care of yourself. Rob,
Yeah.
take care.
Let's see you, John.
All righty.
Hey, good night. And Rob, if you're there, good night to you too. I think he walked away.
Well, I think he did too, but I guess he'll figure out we're gone. Take
Yeah,
care.
I think so. Take care.
7-3.
73.
I'm sure it's Team Viewer. You maximize on Team Viewer if you can, if there's a way.
Yeah, over there. Yeah, there's all kinds of stuff there.
Lower right corner.